a probability distribution, I'll give a definition. It's a list of the probabilities, the probability, I guess, of every possible outcome. So essentially, it's a list of the probability of every possible result. Okay. So for example, we flip 2 coins. How many of them are going to be tails? Now, the way we're going to do this is we're going to define essentially a variable. So I'm going to say, okay, we're going to say that x is the number of tails. And then we're going to make a chart. And we're going to make a chart and we're going to say what values of x could there be and what is the probability of each of those values of x. So if we flip 2 coins, how many tails could we get? So if we flip 2 coins, we can get 0 tails, or 1 tail, or 2 tails. Now the probability of getting 0 tails, here let's make a quick diagram in case you've forgotten how to do this. Down, heads, tails. Okay, so there's 4 possible outcomes. And how many of them have x being 0, x being the number of tails? And that's going to be 1 out of the 4. So it's going to be 1 out of 4. The number of them that's going to be 2 tails is only that one. And the number of outcomes where there's only 1 tail is this one and this one, so 2 out of 4. And for a variety of reasons, we don't actually often reduce the probabilities when we're giving a probability distribution. And there we go. So when we flip 2 coins, how many tails? That's the probability distribution for a possible number of tails. That's a really messed up number 2. Example 2. So we flip 3 coins. So same idea. So we'll draw a little helpful tree diagram over here. So we know kind of what we're talking about. I'm not saying you always have to do that, but we're doing that here. So x, I'm going to define x as, again, number of tails. So x and p of x. For 3 coins, we could either have 0 tails, or 1 tail, or 2 tails, or 3 tails. Those are the possible options. Okay. So there's 8 possible outcomes. How many of them have 0 tails? Just the 1. So that's going to be 1 out of 8. How many of them have 1 tail? That one has a tail. That one has 1 tail. That one has 1 tail. So it's going to be 3 out of 8. If you do the counting, this one turns out to be 3 over 8 as well. And this one turns out to be 1 over 8. One thing to notice, you'll notice that before, if you add up all the probabilities, it adds up to 4 out of 4. It adds up to 100%, which makes sense. If we're listing every probability, the probability of every outcome, something has to happen, so there's a 100% probability that at least something happens. So the probability should always add up to 100%. And here they do. And there we go. So that's our probability distribution for flipping 3 coins in terms of the number of tails. Example 3. We roll 1 die 6. What is the result? I'm gonna use a word here. I'm gonna say that x is number of pips. And pips is it's a nice word. A pip is the dots on the die. So for example, this when you roll a 5, what you have is you see 5 pips on the die when you roll it. Okay, so we have x, and we have the probability of x. And as x is number of pips, or essentially what are we rolling? So we can roll 1, 2, 3, 4, 5, or 6. And what's the probability? The probability of rolling a 1 is 1 out of 6. The probability of rolling a 2 is 1 out of 6. And they're all 1 out of 6. This is actually a special type of probability distribution. We call this one a uniform probability distribution. And why is it called a uniform probability distribution? Because the probability of everything is the same. It's uniform. So there we go.